Hi, my name is Alberto and I'm a game developer. I recently started working on a turn-based strategy game which I'm developing with Unity. In this series of videos, I will be showing the progress and I will be discussing the implementation decisions. Let's start by taking a look to the current state of the project. The game is going to have support for single and multiplayer offline and of course artificial intelligence. The core loop of the game is already implemented. The first phase is the spawning of units by the different players and AIs. Currently, the players can spawn the units in any neutral and accessible hexagon in the grid. The AI does the same process and follows a simple behavior. It places random numbers of units in neighboring hexagons starting in a random hexagon in the grid. After spawning the units, we move to the game loop. The first action is to select one of your hexagons and consequently the units in it. Afterwards, you can select any accessible hexagon within the range of movement of the units group. Note that each hexagon has a maximum capacity of units, and this depends on the environment. In fact, there is a secondary hidden hexagonal grid which has the size of the smallest unit in the game and is used to move units from hexagon to hexagon. The secondary grid is affected by the environment and defines the accessibility of the bigger hexagons. In short, the bigger hexagons, which are the ones that the user interacts with, consist of smaller hexagons, which in turn determine the accessibility of this hexagon. Apart from moving units, we can also enter in combat with neighboring hexagons. Here we can see how the red player attacks the green player and defeats one of the units. The AI currently follows a very simple behavior. It selects the units which are closer to any other player in the grid and move them towards these units or enters in combat if it is a neighboring hexagon. The advantage of working with a turn-based system against a real-time system is that we can create very complex AI behavior. Note that each turn is confined within a single state where the decisions happen. The other players are just waiting for these decisions to happen. Therefore, we can safely use parallelism and multi-threading to process complex algorithms to make these decisions. Now, the current stage of the project is basic and boring to play, but it is the foundation and it allows us to start thinking now on which direction we want to take. Let's now take a look to the core implementation patterns I followed for this game. This game is expected to have several hundred of units at the same time showing up in the screen. Even though this is not a real-time strategy game, the only fact of rendering this number of units in the screen could be an issue in performance using game objects. This is the main reason I decided to follow a simple entity component system. Here I show you the implementation I followed. Note that the entities called units are data structures as well as the components that form them are also data structures. Both the units and the components are stored in unidimensional arrays and share the positions. We initialize these arrays with a capacity which corresponds to the maximum number of units each player can have. And we keep track of the index corresponding to the last position of this array, which is shared among all arrays. In this system, we can easily insert new entities by placing them in the last position and moving the index one forward. Removing entities is also a simple operation. What we are going to do is to move the last entity of the array to the position where this entity is, and we're going to do the same for all the component arrays. Afterwards, we're going to decrease the last index by 1. Now, how do we identify which entities has components and which ones not? We do know at which position of the arrays are the components referring to a specific entity. In order to perform these queries, these checks in a fast way, we are following bitwise operations. This way not only allows us to check if a unit has a specific component, but a combination of components. The other part of the system are the systems themselves. The idea is to implement systems with a single responsibility. These systems will interact with all these arrays of components and units and will define the logic of the game. As you can see, we have systems for rendering units, for movement of units, and all kind of systems related to the hexagonal grid. As an example, I depicted what the unit rendering system is doing because it is very important for the performance of the game. Finally, I wanted to discuss on the other part of the implementation, which handles the different phases that the game is made of. We saw that the game starts with spawning the units. This is considered a state or a phase in the game. Each turn for the humans and for the AI consisted of multiple phases. We started by selecting a hexagon in the grid. Afterwards, we would move these units towards another hexagon, or we would choose to combat with one of the neighboring hexagons. Each of these phases is handled independently in what is called a closed state. Here I depict the state machine corresponding to the level phase. It actually starts at the center where we have a state which handles the transition between the turns. This state accesses the turn system to know which player is the next one. Since we distinguish between human players and AI players, we have two starting nodes. So if the next player is human, we will move to the human selection state, or we will move to the AI selection state in case that it is an AI. This state, as we saw in the game, is just meant for selecting a hexagon in the grid. The moment we've selected, we move to the next state, which is the action state. Over there, we will move to what we call shared states because we can move or we can enter in combat, but these two states are shared by the AI and the humans. It's exactly the same for both. And finally, we complete the loop. We go back to the next turn, so the transition turn state. And that's it for this video. In the next video, I will continue showing the progress and also discussing some of the core features and the implementation side. Thanks for watching and hope to see you next time.